Hello guys, welcome once more to another video again in my channel. So in today's video we are going to be tackling the Cameroon Advanced Level Mathematics GCE June 2020 question 9 of paper 2. Okay guys, I recommend that you should like the video, share the video to your friends and subscribe to the channel, especially if you are a GCE candidate writing a GCE. Why doing this? Because when you subscribe, right, whenever I upload a new video, you'll be the first person to see that video. Okay, so the subscription there is very important as for those who are writing the GCE exams. Okay, all right, so as displayed to you on your screen, you can reach me on the YouTube platform via Mathematics Dreamland for Africa, or on WhatsApp via the telephone number displayed to you on your screen. All right, so without wasting much of our time, let's get started. Okay guys, so that's the equation displayed to you, and we'll be tackling the solution step by step. So actually, if you are if you want to join the WhatsApp community, right, you can actually go to the description of this video. It means just below the video, tap on that description, then you scroll down, you see the link there, the channel link there to that general community for on WhatsApp. Okay, so you can actually share it to your friends so that they can also, because what in the general community, right, we share notes, we try to reason with friends, understand what we didn't get well in class, try to share ideas, PDF, and so on. Okay, so very soon I'll be actually doing the physics part, answering data analysis question and the rest. Okay, biology stuff and the rest. Okay guys, so stay tuned. All right, so let's begin with our solution. Okay, so this is our statement, right? This is our statement. So I can let the mathematical statement be Pn. Okay, so Pn, I can let it to be Pn. It depends on you. I can let it to be anything. Okay, so if I let my statement to be Pn, it means I'm going to handle three cases here. Okay, yeah, I'm going to handle three cases. So sorry for the noise outside. Okay, so in mathematical proof, right, we have just three cases. We have case 1, case 2, and case 3, and a conclusion. Yeah, and a conclusion. Okay, so yeah, I'm going to deal with all the cases. Okay, so with our case 1 here, for the case 1, right, you just let you just prove that the left hand side should be equal to the right hand side. Okay, by putting n equals to 1 and r equals to 1 here. Okay, so that is our first case. Okay, but my left hand side is just 1 divided by 4r squared minus 1, and my right hand side is n divided by 2n plus 1. Okay, so now if I substitute my values, at the end of the day I will have 1 divided by 4 1 squared, 4 times 1 squared minus 1 being equal to 1 divided by 2 times 1 plus 1. Okay, so 1 squared is 1 times 4 is 4, minus 3 is 3, 4 minus 1 is 3, and 1 divided by 2 times 1 plus 1. Now 2 times 1 is 2, and then plus 1 is 3. Therefore, at the end of the day, we are going to have 1/3 being equal to 1/3, and therefore it is true for n equal to 1. Okay, some students might actually be complaining why it is not true for n equals to r, for r equals to 1. Okay, it cannot be true for r equals to 1 actually, because the equation is talking of the question is asking the proof for n in n, not for r in n. Okay, and actually some students just know that at the first stage, right, you just take n equal to 1. If you take n equal to 1, actually you cannot actually go like that, because we have n on the right hand side, but we have r on the left hand side. So as for me, I define my own variables to be, I did mine to be n equal to 1 and r equal to 1. Okay, so that is it. That is why I conclude that it's true for n equal to 1, because the question is talking of n in n, not r in n. Okay, all right, so that is it. So for our case 2, which is the assumption stage, so this is the assumption stage. Assume for n equals to k. Okay, so if we assume that assumption, it means that our summation from r equal to 1 right up to k of 1 divided by 4r squared minus 1 is equal to, so we substitute k where we find n. So these are n here, substitute k here, and k here. So this is the assumption state, the stage of assumption. Okay, so that is it. Now the last case is talking of the fact that here we prove for n equal, for nk implies nk plus 1. Okay, it means that we are using this nk to prove this, to prove nk plus 1. And how are we going to do that? Okay, we have the summation from r equal to 1 right up to k plus 1 of 1 divided by 4r squared minus 1 being equal to k, the summation from r equal to 1 right up to k of 1 divided by r squared divided by 1, then plus the k plus 1 term. I highlighted this in red because it is very important. This is where many students get confused when it comes to this to some proof of this nature. Okay, many students get confused here because some of them don't even include this k plus 1 term, and some don't even know where to substitute this k plus 1 term. Okay, so that is it. Now in this video I'm going to explain where we are to substitute this k plus 1 term. Okay, all right. So this k plus 1 term is actually substituted here. Okay, the k plus 1 term is usually substituted in the on the left hand side of a mathematical proof. Okay, actually I said usually, not always. Okay, all right, so that is it. So what is my k plus 1 term? The k plus 1 term means that I will go to where I find my r, this term here, then I increase it by 1. Okay, so if I go here, I will increase my k by 1. So we have 1 divided by 4 of k plus 1 squared, then minus 1. So since I know my k plus 1 term and I also know this term, so this term highlighted in green here. Okay, so we know that the summation from r equal to 1 right up to k of 1 divided by 4r squared minus 1 is equal to k divided by 2k plus 1. Okay, therefore where I will see this, I will replace it with this. So at the end of the day, I'm going to have this. Okay, now having this, we haven't substituted the k plus 1 term here there. So if we substitute it at the end of the day, we have this. Okay, so we have the summation from r equal to 1 right up to k plus 1 of 1 divided by 4r squared minus 1 being equal to k divided by 2k plus 1, then plus our k plus 1 term, which is 1 divided by 4 of k plus 1 squared minus 1. So this point here is very important, this k plus 1 term, because even in the further math sequence and series, some students actually get confused here. Okay, all right, so let's continue. Okay, so this is where we ended. So that is it. Now there is an important result here. I recommend that you can pause the video. You can pause the video and then you think of this important result that is here in the denominator. Okay, if we look at things here, if we define a variable, say x, to be equals to all this, it means that at the end of the day we are going to have 4x squared minus 1. So here it means we have 4x squared minus 1, which is totally difference of 2 squared. So for difference of 2 squared, we write this 4x squared minus 1 as 2x plus 1 times 2x minus 1, or 2x minus 1 times 2x plus 1, depends on you. Okay, so this result here is actually difference of 2 squared. Okay, so this part is very important. It's difference of 2 squared. Okay, so if we apply it, if you apply the difference of 2 squared, at the end of the day we are going to have the summation from r equal to 1 right up to k plus 1 of 1 divided by 4r squared minus 1 equal to k divided by 2k plus 1, then plus 1 divided by 2 of k plus 1 all squared minus 1. Why did I condense this part again like this? It's because this part is actually difference of 2 squared in terms of this x here, but for clarity I've just expressed everything here. Everything here should be squared. Okay, that is it. So I've not changed anything here, because if I take 2 squared, I will still have 4. I take k plus 1 squared, I will still have k plus 1 squared. So at the end of the day, I will still be left with 4 of k plus 1 squared. So it's the same thing. Now, as from here, right, we can actually express it now as a difference of 2 squared clearly. Okay, So that is it. So now, so at the end of the day, we have this. Okay, yeah, so that is it. All right. We can actually come now to this our bracket. So for difference of two squares now, right? We have 2 of k plus 1 minus 1 times 2 of k plus 1 plus 1. So it's the same thing. I'm not changing anything here because this is actually difference of 2 squared. Applying this principle up here. Okay, so that is it. Now from here we can actually expand this bracket. So if we expand the bracket, we are going to have this, because let's expand it. We have 2 times k is 2k, 2 times 1 is 2, then minus 1 there. And here 2 times 2 is 2k, 2 times 1 is 2, then plus the 1 there. So it means at the end of the day, we are going to have k divided by 2k plus 1 plus 1 divided by 2k plus 1 times 2k plus 3, because 2 minus 1 is actually 1 and 2 plus 1 is actually 3. So at the end of the day, we have that. Now from here, this is an important part too, where many students actually get confused factoring out a factor, okay, or factoring out the term. Okay, so we have k divided by 2k plus 1 plus this, right? So you notice that we have a 1 divided by 2k plus 1 here, then times k. Okay, because I can write this k divided by 2k plus 1 as 1 divided by 2k plus 1 times k, such that if the k multiply to it, it will just be this one. Okay, so in this other side too, we can still split this other side as 1 divided by 2k plus 1 times 1 divided by 2k plus 3. Okay, so that we can factor out one of the 1 divided by 2k plus 3. We can factor out 1 divided by 2k plus 3 with this other one, because there are already 2 of them. So if we factor out 1, at the end of the day, we are going to be left with 1 divided by 2k plus 1 times k plus 1 divided by 2k plus 3. It is clear, because if I decide to expand this bracket, I will still arrive back at this point up here. So let's try that. So I have 1 divided by 2k plus 1 times k. I will have this 1 divided by 2k plus 1 times 1 divided by 2k plus 3. So I will have this 1 divided by 2k plus 1 times 2k plus 3. So it's the same thing. Now I'm going to handle this part. So we are going to handle this part, leaving this other part constant for now. Okay, so if I handle this part, this is what we are going to have. So this only for this part, we have k divided by 1 plus 1 divided by 2k plus 3. Okay, why did I include 1 here? Because writing k is like saying k divided by 1. So this is just for conveniency, as we are going to see. Okay, all right, my LCM here is actually 2k plus 3. Okay, so if I look for my LCM, it will be 2k plus 3. Okay, so that is my LCM. Now if I take the LCM now and I divide by 1, I will still have the same thing. The result now, I will multiply by k. So if I multiply 2k plus 3 times k, I will have k into 2k plus 3. Now I take the same result, this my LCM again. I divide by this other 1 here, I will have 1. The 1 multiplied by this other 1, the numerator, I will still have 1. So that is why I have my 1 here. And then you can notice that this is just equal to this. Okay, so it means we are going to substitute this now here. Okay, so at the end of the day, I'm going to have this. Okay, so I have 1 divided by 2k plus 1 times k into all this, then plus 1 divided by this. Okay, so we can actually expand this bracket. If we expand it, at the end of the day, we will have this. Okay, so if I 2 times 2k is 2k squared, 2 times 3 is 3k, and then plus 1 divided by 2k plus 3. So being equal to this. Don't forget that we are using the k plus 1 term and the nk term to prove this. So we are still under the proof, such that the proof should end with something k plus 1. Okay, it means we are increasing the k term by 1. Okay, so that is it. So now notice something here. We have a quadratic here in the numerator that we can solve either by formula method, factorization, or by completing the square. But I'm going to use factorization here. It is not actually good to use all those completing the square formula method, because it is actually time consuming. But there are some that is good to use that formula method, because not all quadratics are factorizable. Okay, all right. So here is my quadratic, that this is my a, this is my b, and this is my c, which is a constant. So I'm going to look for two terms which if I multiply will give me a c, and if I add will give me b. So this is my a and this is my c. 2 times 1 is 2, which is my AC. And if I take the same 1 and the same 2 and the 1, if I add them, it gives me 3. And therefore, my two values are 2 and 1. Okay, so at the end of the day, I'm going to have 1 divided by 2k plus 1 times my 2 and my 1. So these are my two values that my two factors. Okay, so that is it. Now from here, we notice that this 2k plus 1 is common in the numerator too. So it means this one will cancel with this other 1 down here. And at the end of the day, we will be left with 1 times k plus 1 divided by 1 times 2k plus 3, which is still k plus 1 divided by 2k plus 3. So this is it here. And this is still equal to k plus 1 divided by 2 of k plus 1, then plus 1. Because if I decide to expand the bracket, I will say arrive at this point. Okay, let's do it again. 2 times k is 2k, 2 times 1 is 2. Then the 2 multiplied will be added to this one to give us 3. Okay, so it is clear. Now there is a reason for me doing this, because at the beginning of the video I explained that if you have that question of that format, that you have n divided by 2n plus 1, right, make sure that at the end all of your values, all of your n values will be increased by 1. So it means that's why we have k plus 1 divided by, here we had 2n plus 1 according to the equation, but here we have 2k plus 1, means we have to increase every term by 1. Okay, that is why we have the summation from r equal to 1 up to k plus 1 of 1 divided by 4r squared minus 1 being equal to k plus 1 divided by 2 of k plus 1 plus 1. And this, with this, we have successfully proved that nk implies nk plus 1, since we use the nk and the k plus 1 term. So be careful with that t plus 1 term, k plus 1 term, please. It is very important. Okay, therefore, since the statement Pn is true for n equal to 1, assume true for n equal to k, and k implies nk plus 1, it is true for all n in n. So this conclusion is very important, because if you miss this conclusion, you lost the market. That is it. All right, so this is the end of the mathematical proof. All right, so let's continue. So the Roman 2 part says a relation R is defined on Z, the set of integers, by A related to B. So it implies A minus B is even. Show that R is transitive. Okay, so we are in this video, the solution is somehow short, so I decided to emphasize on some properties of relations. Okay, all right, so let's begin with property 1, which is transitive. So a relation R on a set A is transitive whenever A is related to B and B is related to C, then A is related to C. So let's assume that can I be put, in fact, mathematically, let's first look at the mathematical expression. So mathematically, for all A, B, C in A, if A is related to B and B is related to C, implies that A is related to C. So let me say I am A and you are B, and let me say your father is C. Okay, now if I'm A, you are B, and your father is C, it means if I'm related to you, right, and you are related to your father, it therefore means that I'm actually related to your father too. Okay, I hope it is clear. I'm A, you are B, and your father is C, right? So if I'm related to you and you are related to B, it therefore means that I'm actually related to your father too. Okay, so if you're related to your father, it means I'm actually related to your father. Okay, that is it. All right, so let's look at the property 2, which is reflexive. So a relation R on a set A is reflexive if every element is related to itself. It means that mathematically, for all A in A is related to A, and that is all. So that is property 2. And these properties, they are very helpful in paper 1 when answering paper 1 questions. Okay. All right, let's continue. So the symmetric property property. Yeah. So a relation R on a set A is symmetric whenever A is related to B and B is related to A. Okay. So mathematically, it is symmetric for all A, B in A. A is related to B implies B is related to A. Okay. So that is it. And this, as I emphasize, these properties, they are very helpful in paper 1. Okay, they are very helpful. So a relation R on a set A simply means that the set A contains all A, B. From here, the set A contains all A, B, and C. Okay, yeah, that is it. And this is just the relation. Okay, so that is it. All right, but here we have just A in A. It means the set A just contains the small letter A in it. Okay, that is it. Okay, so if you look at property 4, which says antisymmetric. Okay, a relation R on a set A is antisymmetric whenever A is related to B and B is related to A. Okay, then implies that A is equal to B. So that is the antisymmetric property. It says that if A is related to B and B is related to A, it therefore means that A is just equal to B. So that is the antisymmetric property. Okay, yeah, that is it. So please, I don't know, I don't know. So let me just use the other example again. Yeah, the other one. So if I'm A, you are B, right? So if I'm related to you and you are related to me, it therefore means that I'm just equal. It's like I'm you already. Okay, it means you and I are actually equal. Okay, it means, let me just say we have a party and then we have to go there, and I'm like you are like me. It therefore means that if I go there, many people will see me like you. Okay, so that is just a simple way of reasoning all this stuff. So that is talking about the antisymmetric property. Okay, so that is it. That is it. All right, so let's continue. So this is the property 5, which says equivalent relation. So this is the equivalent relation, right? It's just talking about the fact that you have to know all these other properties offhand. So if you know the transitive properties, reflexive, symmetric, and antisymmetric, it means you have to know equivalent relation and other pair. Okay, so that should be it. All right, so an equivalent relation is one that is transitive, reflexive, and symmetric. Sorry. So a relation is said to be equivalent relation if it is transitive, reflexive, and symmetric. Okay. All right. So it means you are just to prove, if they can ask you that. Anyways, let's just do a partial order. So what is actually a partial order? A relation is partial order if it is reflexive, antisymmetric, and transitive. So you notice here that between equivalent relation and partial order, it's just that symmetric and antisymmetric that is changing. Okay, so if you are asked to prove that a relation is equivalent, it simply means that you are to prove this property. If you prove this transitive property and then you prove the reflexive property and also the symmetric property, it means that you conclude that that relation is equivalent relation. Okay, while for partial order is the same thing. Proof for reflexive, antisymmetric, and transitive. Then you conclude that it is a partial order. Okay. So with this, we can look now for our solution. Okay. So our solution. So let's read the question again. A relation R is defined on Z, the set of integers by A is related to B, implies A minus B is even. Show that R is transitive. Okay. So A related to B implies A minus B is even. That is a very important, this point is very important. Is even. This is already the interpretation of the equation. Is even. What does that simply mean? So from a transitive property, A is related to B. So from this property here, if A is related to B, B is related to C, implies A is related to C. Okay, so this is the same property here. So you see, I'm going to use that property to solve this particular question because they have mentioned transitive there. Okay, so just the transitive, it means I'm going to use this property. Okay, so that is it. So if this is even in mathematics, right, if a number is even, it means it can be written in the form 2p. okay, or 2m, or 2 anything, depends on you, 2 any figure, but it should not be 2 something plus 1. No, it should just be 2p, 2m, 2q, or 2 whatsoever, but it should not be, if I write 2p plus 1, it means that is odd, if a number is odd. So yeah, they said a minus n is even. So sorry, here was supposed to be b. Sorry for that. A minus b is even implies that I can write this as, if a number is even, I can actually write this as 2p. Okay, so we can call this equation 1. But the transitive property says that if a is related to b and b is related to c, implies a is related to c. So now this is my a is related to b. According to the format that they gave us, that a minus b is even. So it means I'm going to use b minus c, which is also even again. Okay, so that is it, b minus c, which is even. So it is 2q, and this is my equation 2. Now I can solve these two equations simultaneously for me to prove that it is a is related to c also. Okay, so solving 1 and 2 implies, if I solve these two equations, right, I have a minus b equals to 2p and b minus c equals to 2q. Now this is a simultaneous equation, and we can solve them at the same time. Now I can subtract for me to solve it, but I can actually figure out that I have a negative b here and a positive b here, and if you add a negative number to a positive number, that number disappears to 0, or it tends to 0. Okay, so it means that negative b plus b is 0, and therefore a plus minus c is still a minus c. Okay, therefore at the end of the day, I'm going to have a minus c being equal to, now 2p plus 2q is 2p plus 2q. Okay, is the same thing. Okay, so now what do you notice? We notice that we can actually factor out 2. So if you factor out 2, at the end of the day, we are going to have a minus c being equal to 2 of p plus q, and we can actually define a variable, say m, to be equal to p plus q. Okay, such that our a minus c is just equal to 2m, and as I earlier said, a number is said to be even if it can be written in the form 2m, 2q, 2z, 2 anything. Okay, so that is it, and this is actually even. Okay, so it implies that hence r is transitive, since we have proven it. Okay, all right, so that is actually the end of the video. Okay, so I recommend that you should stay tuned for more videos, share to your friends, subscribe to my YouTube channel so that you can benefit from it all day long. All right, see you guys in the next video.